In this lesson, we'll multiply square root of 8 and square root of 2 step by step with a quick visual cue that puts everything under one root, and then an alternate break-apart method. Step 1. Write the expression. Step 2. Use the product of roots property. It reads, the square root of a times the square root of b equals the square root of a times b for non-negative a and b. So, square root of 8 times square root of 2 becomes the square root of 8 times 2. That equals the square root of 16. Notice 16 is 4 squared. Therefore, the square root of 16 equals the square root of 4 squared, which is 4. That's our answer by the one-root method. Now, the alternate break-apart method gives the same answer quickly. Step 1. Simplify the first radical. Square root of 8 equals square root of 4 times 2, which is 2 square root of 2. Now multiply by square root of 2. 2 square root of 2 times square root of 2. That's 2 times the square root of 2 times 2, which is 2 times the square root of 4. So we get 2 times 2, and that equals 4, matching our earlier result. Summary: putting radicals under one root or breaking a perfect square factor out both lead to the same answer. Final result equals 4. We will factor the expression 25y squared minus 17. The key idea is the difference of squares pattern. A squared minus b squared equals the product, a minus b times a plus b. First, rewrite each term as a square. 25y squared is open parenthesis 5, y close parenthesis squared. And 17 is the square of square root of 17. So we can take a equals 5y and b equals square root of 17. Now substitute into the pattern a squared minus b squared. Our expression becomes open parenthesis 5, y close parenthesis squared minus open parenthesis square root of 17 close parenthesis squared. By the formula, this equals open parenthesis 5, y minus square root of 17 close parenthesis times open parenthesis 5, y plus square root of 17 close parenthesis. Quick check. Expand to see the original expression. First multiply. Open parenthesis 5 y close parenthesis times open parenthesis 5 y close parenthesis plus 5 y times square root of 17 minus square root of 17 times 5y minus open parenthesis square root of 17 close parenthesis squared. That simplifies to 25 y squared plus 5 y root 17 minus 5 y root 17 minus 17. The middle terms cancel. We get 25y squared minus 17, which matches the original expression. Therefore, the complete factorization is open parenthesis 5y minus square root of 17 close parenthesis times open parenthesis 5 y plus square root of 17 close parenthesis.
In this short lesson, we will factor the expression 25y squared minus 7, and we will do it step by step with a fast visual cue. Here is the expression we want to factor. Step 1. Recognize a classic pattern called the difference of squares. The identity says a squared minus b squared equals open parenthesis a minus b close parenthesis times open parenthesis a plus b close parenthesis. Step 2. Rewrite each piece as a perfect square. 25y squared is the same as open parenthesis 5 y close parenthesis squared, and 7 is the same as open parenthesis square root of 7 close parenthesis squared. Putting that together, the original expression becomes open parenthesis 5 y close parenthesis squared minus open parenthesis square root of 7 close parenthesis squared. Step 3. Identify a and b. Compare with a squared minus b squared. Here a equals 5y, and b equals square root of 7. Step 4. Apply the identity. Replace a squared minus b squared with open parenthesis, a minus b close parenthesis times open parenthesis, a plus b close parenthesis. Step 5. Write the final factorization clearly. 25y squared minus 7 equals open parenthesis 5, y minus square root of 7 close parenthesis times open parenthesis 5, y plus square root of 7 close parenthesis. The fast visual cue is see two perfect squares separated by a minus sign, then immediately think factor as a minus b times a plus b. And that is the complete, no skipping solution. Nicely done.
We will evaluate the expression ln of 32 divided by ln of 2 step by step. First, recognize that 32 is a power of 2. 32 equals 2 to the 5th power, because 2 times 2 times 2 times 2 times 2 equals 32. Use the logarithm power rule. The rule says ln of a to the b equals b times ln of a. Applying the rule to ln of 32, we write ln of 32 equals ln of 2 to the 5th equals 5 times ln of 2. Now substitute this back into our fraction. Replace ln of 32 by ln of 2 to the 5th. Then, by the power rule, that equals 5 ln of 2 over ln of 2. Since the same factor ln of 2 appears in the numerator and the denominator, they cancel. We can write 5 times ln of 2 over ln of 2 equals 5 times 1. Therefore, the value of the expression is 5. Answer 5. In this lesson, we will factorize the expression using a fast visual cue. Read the problem. Factorize y squared minus 16. Step 1. Spot perfect squares. 16 is 4 squared. Rewrite the expression so both terms are clear squares. Step 2. Recall the difference of squares. A squared minus b squared equals open parenthesis, a minus b close parenthesis times open parenthesis, a plus b close parenthesis. Step 3. Match the pattern to our expression. Let a equal y and let b equal 4. Step 4. Apply the formula with a equal y and b equal 4. Substitute to get open parenthesis, y minus 4 close parenthesis times open parenthesis, y plus 4 close parenthesis. Step 5. Conclusion. The factorization is open parenthesis, y minus 4 close parenthesis times open parenthesis, y plus 4 close parenthesis. In this lesson, we will evaluate the expression open parenthesis 81 over 625 close parenthesis to the negative 1/4. Step 1. Rewrite the negative exponent as a reciprocal. A negative exponent means a to the minus n equals 1 over a to the n. Apply it here. We flip the fraction and make the exponent positive. First, write it as 1 over the 1/4 power. And then flip to get 625 over 81 to the 1/4. Step 2. Interpret the 1/4 power as a 4th root. X to the 1/4 equals the 4th root of x. So our expression is the 4th root of 625 over 81. A root of a fraction splits across numerator and denominator. The 4th root of a over b equals the 4th root of a divided by the 4th root of b. Step 3. Recognize perfect 4th powers. 625 equals 5 to the 4th, and 81 equals 3 to the 4th. Therefore, the 4th root of 625 is 5, and the 4th root of 81 is 3. So the fraction becomes 5 over 3. Final answer, 5 over 3. We will simplify a rational expression step by step with clear visual cues. Our target is the fraction. A squared b cubed c to the x over a to the 5th, b to the 4th, c to the 1st. Step 1. Write the numerator with its exponents, and write the denominator with its exponents. We will keep the text thick and add highlights to guide our eyes. Step 2. Group like bases and subtract the exponents. For a squared over a to the 5th equals a to the 2 minus 5, which is a to the negative 3. For b, b cubed over b to the fourth equals b to the 3 minus 4, which is b to the negative 1. For c, c to the x over c to the first equals c to the x minus 1. Step 3. Combine the three results. We get a to the negative 3 times b to the negative 1 times c to the x minus 1. Step 4. Rewrite using only positive exponents. Negative exponents mean the factor belongs in the denominator. So a to the negative 3 becomes 1 over a cubed, and b to the negative 1 becomes 1 over b. Therefore, the product becomes c to the x minus 1 over a cubed b. Final answer, c to the x minus 1 over a cubed b. We will visually prove, step by step, that the fraction of log base b of x to the third power over log base b of x equals 3. First, write the original expression on screen. Step 1. This is our starting fraction. Log base b of x to the third power over log base b of x. Step 2. Use the power rule for logarithms. The power rule says, log base b of a to the power p equals p times log base b of. Apply it to the numerator by pulling the 3 down. Step 3. Now the fraction is 3 times log base b of x over log base b of x. So, a common identical factor appears in the numerator and denominator. Step 4. We can cancel the identical factor log base b of x in the numerator and in the denominator, as long as log base b of x is not 0. That requires x greater than 0 and x not equal to 1, and the base be greater than 0 and b not equal to 1. Now perform the cancellation. Step 5. Therefore, the fraction simplifies to 3. Quick visual recap. Start with the original fraction. Use the power rule to pull the 3 down. Spot the common factor log base b of x. Cancel the common factor to get 3. Done. We will solve the square root of 25 squared minus 24 squared using the difference of squares pattern, step by step, without skipping any step. Step 1. Write the original expression. Step 2. Recognize the identity. A squared minus b squared equals the product of a minus b and a plus b. Here, a equals 25 and b equals 24. Step 3. Factor the inside. Using the identity, it becomes the square root of open parenthesis 25 minus 24 close parenthesis times open parenthesis 25 plus 24 close parenthesis. Step 4. Compute each factor. 25 minus 24 equals 1, and 25 plus 24 equals 49. Now write the result inside the radical as 1 times 49. Step 5. Multiply inside the root. 1 times 49 is 49. So we have the square root of 49. Step 6. Take the square root. The principal square root of 49 is 7. Final answer, 7. Summary. The difference of squares turns a big subtraction into a tiny product. 1 times 49, whose square root is 7.
In this lesson, we'll evaluate the expression open parenthesis 49 over 25 close parenthesis to the power negative 1/2. We'll move slowly, highlight each rule, and never skip a step. Step 1. Use the negative exponent rule. For any non-zero, a to the power negative n equals 1 over a to the power n. Here the base, a, is 49 over 25, and n is 1/2. So our expression becomes 1 divided by open parenthesis 49 over 25 close parenthesis to the power 1/2. Step 2. Rewrite the 1/2 power as a square root. A to the power 1/2 equals the square root of a. Therefore, the denominator is the square root of 49 over 25. So the whole expression is 1 over the square root of 49 over 25. Step 3. Split the square root across numerator and denominator. The square root of a fraction equals the square root of the numerator over the square root of the denominator. The square root of 49 is 7, and the square root of 25 is 5. So the square root of 49 over 25 equals 7 over 5. Step 4. Go back to our expression 1 over the square root and substitute 7 over 5. We get 1 divided by 7 over 5. Dividing by a fraction is the same as multiplying by its reciprocal. So 1 divided by 7 over 5 equals 1 times 5 over 7, which equals 5 over 7. Therefore, the value of open parenthesis 49 over 25 close parenthesis to the power negative 1/2 is 5 over 7. Quick recap. Negative exponent makes a reciprocal. 1/2 power becomes a square root. Simplify the square root to 7 over 5, and take the reciprocal to get 5 over 7.
Thank you for watching. Tap like, share, and comment, and then follow and subscribe for more quick problem solving tips. Let's make maths simple. One video at a time only on MyVerse Maths.